Today's lesson is complex numbers with operations. First, before we get started, let's review what complex numbers are. Complex numbers are any numbers that can be written in the form a plus bi, where a acts as the real part and b acts as the imaginary part. Here are some examples. 7 plus 4i is a complex number, and so is 2 minus 6i. Now that we have reviewed complex numbers, let's add the operations addition and subtraction. To add or subtract complex numbers, you first have to combine the real parts together and then combine the imaginary parts together. Let's start with the example 1. It says to simplify. To solve addition and subtraction with complex numbers, we have to follow these steps. Step 1 is to combine the real part. Then, step 2 is combine the imaginary part. Step 3, solve the real part. Then step 4, solve the imaginary part. So how about we start with A? It says 6 minus 4i plus 1 plus 3i. To solve A, the first step says to combine the real part. So 6 plus 1. Next, step 2 says to combine the imaginary part. So, negative 4i plus 3i. The third step says to solve the real part. So, 6 plus 1 equals 7. Now, our final step says to solve the imaginary part. So, negative 4i plus 3i is negative I. So, our solution is 7 plus negative I, or 7 minus I. Now, here's a subtraction problem. B says 3 minus 2i minus 5 minus 4i. We just have to follow the same steps as we did for the addition problem. First, combine the real part. It would be 3 minus 5. Next, we have to combine the imaginary part. Negative 2i minus negative 4i. Always remember your signs. Now solve for the real part. 3 minus 5 is negative 2. Our final step is to solve for the imaginary part. Negative 2i minus negative 4i is positive 2i. So our solution is negative 2 plus 2i. How about you try a few problems of your own and follow the 4 steps as you go. Then when you are done, check your answers with mine. These are the answers to problems A and B. A is 12 plus 4i, and B is 10 plus 2i. Now let's try multiplication with complex numbers. Multiplying complex numbers is different from adding and subtracting complex numbers. You have to use the FOIL method in order to solve the problems. There are 4 steps to multiplying complex numbers. Step 1, FOIL the complex numbers. Step 2, combine imaginary part. Step 3, change I squared to a negative 1. And step 4, combine all like terms. Since we know the steps, let's try example 3. A says 2 plus I times 5 plus 2i. Step 1 says to FOIL, so multiply first numbers, which are 2 and 5, then the outer, which are 2 and 2i, then the inner, which are I and 5, and then the last, which are I and 2i. It would look like this. Now that we have FOILed, next we have to combine the imaginary parts, which is the 4i and 5i. So we would add them both together to get a 9i. Next, we are on step 3. That says we have to change I squared to a negative 1. So it now will look like this. Our final step is to combine all like terms that are last. So we would combine 10 and -2, which would give us 8. So the answer to this problem is 8 plus 9i, and that is our solution. Try these two problems on your own. Don't forget to follow the steps. Then check your answers with mine when you are done. These are the answers to problem A and B. A is 42 minus 2i, and B is 25. Now let's move on to division with complex numbers. Division is different from any operation with complex numbers. For in division, two complex numbers of the form a plus bi are called complex conjugates. You can use conjugates to simplify the quotient of two complex numbers. Let's walk through example 5 together by using the 5 steps, which are step 1, multiply by the conjugate, step 2, multiply, step 3, I squared equals -1, step 4, combine like terms, and step 5, put into standard form. The first step is to multiply each side by the conjugate, as I did. I multiplied on the bottom 2 minus 4i, and on the top 2 minus 4i. Step 2 is to multiply by each side, as I did. I multiplied 3i by the conjugate and 2 plus 4i by the conjugate to get, on the top, 6i minus 12i squared, and on the bottom, 4 minus 8i plus 8i minus 16i squared on the bottom. Step 3 is to change I squared into -1, as I did for -12i squared and for -16i squared. The fourth step is to combine all like terms, as I did for 4 plus 16. And the final step is to put it all back into standard form, as I did by our solution is 3 over 5 plus 3 over 10i. Now try this problem on your own, and don't forget the steps. Then check your answers with mine. Now check your work and see if you got the right answer. I got 10 minus 6i over 17. By doing all of this, you probably think, what is the whole point in imaginary numbers? But they actually are used in real life. For example, it is used in electricity. For this problem says, in an AC circuit, the voltage E, current I, and impedance Z are related by the formula E minus I times Z. Find the voltage in a circuit with currents 1 plus 3J amps and impedance 7 minus 5J ohms. As you can see by my problem, as I set it up and multiplied by using 1 plus 3J and 7 minus 5J as the conjugates, and then use multiplication, I got an answer of the voltage is 22 plus 16J volts.